Back to Generative Software Engineering, and today we will look at a concrete example of how to extract the... Okay, so welcome back to Generative Software Engineering, and today we will look at a concrete example of how to extract the construction part of a software product line from existing implementations. So at some point, companies, they will have to go from individual products that they maintain to a software product line that is then also able to generate the different products. So we need a different kind of representation. Last time we looked at variation mechanisms, and we said that the preprocessor based one is the most popular variation mechanism that allows the configuration of products from existing code. We had a few others like delta application or the annotation of models that we can extract then. And we had also, I think there was also the one based on simply inheritance and parameterization of the systems. But here in industry, the most common one is using if-defs. And we will have a look at some example where it makes or might make sense to go from individual software products that we maintain to a software product line. So we have a small company that creates robots. Let's check. These kinds of robots, and they have different features. So the company has different implementations of these robots. Here are, there's a list here of different implementations. The main difference might be that two versions are based on different microcontrollers. So this version here is based on the, it didn't work. So they're all here. So this version here is based on an ESP8266 chip, whereas the other versions, they are based on the ESP32 chip. So different hardware, but very similar capabilities of the robots. And then there are some variants of the robots. For example, there's one which is just the basic driving based on the ultrasonic sound sensor. So this would be the implementation of that one. And let's see if we can flash this on the robot, then I can demonstrate that this is a very, very basic functionality. So that looks good. This code basically just defines the pins of the microcontroller, sets up the motors, and then the main code that is executed over and over is measuring the distance to obstacles based on the ultrasonic sound sensor. And then basically based on the distance, it decides that it's either going or that it's turning. And this, I have to press the button to upload. Yep. And basically, this is all it does. Based on the distance, it decides that it goes forward or that it turns. So now, it uploaded it. So let's plug that in. Yep. Ja, kein Problem. Okay, so we will need to connect the motors, and then it goes. No. Oh, we're missing some cables. I'm sorry. These cables should be connected somewhere. I'm just guessing that they might need to go here. Yeah, that kind of makes sense. a somewhat stable behavior. That's the problem of putting this thing in a backpack. But yeah, very simple behavior just based on an ultrasonic sound sensor. Now, to make it a little bit more interesting, there are other variants. So there's, for example, a variant that extends this one with an emergency switch. So right now, if we want to stop this, we can't really stop it easily. So we extend the implementation with an emergency switch, and the emergency switch is based on a feature of this controller that allows us to read whether a particular pin is touched. So I already connected this cable to the pin. So if this is touched, it should register a touch signal that then allows the robot to decide that it is stopping. So if the value of the touch, it's a value from 0 to 100. If it's greater than 30, then it's not touched, and we do the normal behavior. Otherwise, if it's less than 30, then we're stopping. So let's upload that. It's right now compiling. Okay, and uploading. So let's start it. I hope all these cables are still connected well. And now it should be driving again. Yep. And now if we press, come on. No. Really don't know why this guy always works at home and never in the lecture. This is crazy. This is pin D4. And is reached from pin 4. How come? Well, it worked a few days ago. This is really crazy. Let's see what's going on. Let's debug this. That's actually another feature. So this variant of the robot has a we do some printing to the serial port, and this will allow us to read the values that the robot is that the robot is sending. So we can start the serial motor. The duration is something that was measuring the echo of the ultrasonic sound sensor. And you see if I put my hand close, the number that we see after duration, that's the distance. So if I move my hand further and closer, we see that the distance thing works. The other number that's printed, that is the capacitive touch feature. And we see that this now, when I touch this, it goes down to something like 11, which is less than 30, right? And this means it should be stopping, right? Let's connect the power. Yeah, it works now. I have no idea why it didn't work when it was on camera. Yeah, it's really crazy. Just for the record, this is the emergency off, and if I press it, it stops. Just to prove it to the people that are only watching this on YouTube, the emergency off actually works. Yeah. Oh, and wait. Yeah, it actually still works. Good. So now we demonstrated another feature, this option to debug the code, or at least to trace some of the information that are going on the system. So this is another nice feature in this product. Not all of the products have it. Some of the more basic ones, they don't have this option, because sometimes it's not really desirable. Sometimes we don't have the computer connected. Then we might not want this printing to happen. So right now, the only way to do that is to copy and paste, and then maybe delete all of the printouts to the console. So we had, there is another variant here, which is a full featured one, which has everything that we used in the previous sessions. Then there's one which is called Lean. So what we can observe is that the different versions that we are, let's just recompile this. So this was the one with the emergency off. I'm just going to recompile it so that we can see the output down here, because there are actually some differences between the versions and how much, say, memory consumption they have on the actual embedded chip. So here, this uses 18% of the program storage. So you might expect that if we have a less capable chip, or if we extend the program a bit, then 18% is good. But if we have something that uses more, then maybe that's not so good. So let's look at the full featured version, this one here, and see what happens if we compile that. If we compile that, we can expect that it uses a lot more resources on the chip. So this one has the Wi-Fi connection. It is able to read stuff in JSON format from the computer that is running the corresponding program. And it also has this for easier configuration. It has a Wi-Fi manager on board. So what happens is that if it can't find a Wi-Fi that it can connect to, it will create its own Wi-Fi hotspot, and then we could configure it using that hotspot and give it the credentials of an existing Wi-Fi that it should connect to, which is quite advanced and taking a long time to compile, as we see. Isn't there like a way to go to high performance or something? Okay. So this one instead uses, so the previous one was using 18% of the program storage space. This one uses 62. So yeah, there are some performance considerations between these versions. This one takes also much longer to compile. So yeah, these are some of the different products. Now the goal is that we actually want to transform this into a software product line, because we want to have many more of these robots and we want to have many different versions of these robots. So we had a quick look at the systems. Now what we should do is we should extract features and demonstrate their relation in a feature model, and then we should list the existing products and we should identify additional ones. So the existing products, those are those 5 or 6 implementations that we have, but we should then list them as a set of features. So the first thing is we extract a feature model of the different, that captures the differences in the implementations and also the commonalities, because some things they might have in common. And then based on that feature model, we will derive a new representation of the robot in code that will allow us to actually generate the different variants of the robot automatically based on feature configurations. So the first step would be to create a feature model. So I'm going to start collecting some features. I think we can just do this together. Because we already had these as an exercise a few times. So I'm going to switch to the document camera. So what would be the root of the feature model? The root might be this robot, right? So the root feature might be the robot. Then what are different features that the variants had? So I'll just make this, put this on the side, and then give you back this overview of the different variants. So we saw one of the main distinctions is the chip that they are based on. So one is based on, one implementation is based on the ESP8266. The other one is based on the ESP32. How would we show this in the feature model? Yeah. So we have the chip feature, and then we have the ESP8266 and the ESP32, and an exclusive OR between them. And how do we link it to the parent feature? Mandatory, yeah. So we just put a line. We could have this filled in circle, but that's sometimes optional. Okay. Now, what were the other things that we had? Wheels. Okay, wheels. But do they differ? Do these implementations differ in the wheels? Or are they all common? So if they are common, then we don't really need to represent them, because there's only they're not relevant for the configuration of the different products. So we're looking for things that are different in the different products. So one of the examples here, we can have a look at the implementations. well, maybe that's a bit more tricky one. So this one here, we had this tracing of information at runtime. I would say that's something that in some cases, maybe for performance issues, we don't want it. We don't want here this conversion of a long integer to a string, printing it. Maybe we want to skip that because maybe we have a high performance robot that shouldn't bother with additional computations. So this would be one feature because we want to keep it for some, right? It helped us to debug this emergency off. So this is like a tracing feature maybe. And this is optional because in some robots we want it, in others we don't. What else is there? So this robot, wait, sorry? Yes, so the first robot didn't have the emergency. This one has the emergency. Okay, so yeah, it's getting a bit full. Let me go back to this, and that's optional, mandatory, optional. Emergency switch, okay. Yeah. Yes, we have an optional Wi-Fi manager. Actually, we had, I mean, here we didn't, sorry, this is the one with the Wi-Fi manager, right? And here, this was the really basic one. This didn't have any Wi-Fi. So there's one, this one here, which doesn't have the Wi-Fi manager, but it relies on Wi-Fi because it has these HTTP requests and gets JSON responses on how to control the motors, right? This is the one that we used for the code generation and for the synthesized controllers. So it queries the laptop of, hey, what do I do? And the laptop is running the generated code. So this one still has Wi-Fi, but no Wi-Fi manager. How do we... And the very first one that I showed today didn't have any Wi-Fi at all. It just depends on the sensor readings, right? So how do we... We could try that, yes. So we know that Wi-Fi manager, we want to put it somewhere here, right? And the question is, do we put wireless here and then do we put a sub-feature Wi-Fi, or isn't that the same? I mean, it's basically they're using the same Wi-Fi library, whether they are whether they have the Wi-Fi manager or not, they basically use the same library code. So this one didn't have any. This one is the one that uses the Wi-Fi manager, and this one just uses regular Wi-Fi. But then the rest they kind of share. And okay, so how do you want to put this in the feature model? Was there something that excludes the Wi-Fi manager? Or would you put a regular or? If you would say this feature is called wireless, would you then put an or between Wi-Fi manager and Wi-Fi? But you can't really have the Wi-Fi manager without having the Wi-Fi functionality. Yeah? Like that? Okay, and then Wi-Fi manager would be an optional one, right? I think this kind of makes sense for the kind of products that we have, yes? So we had the one without Wi-Fi, then we had one with Wi-Fi but no Wi-Fi manager, and then we have one with both. Then actually there was some emergency switch functionality that we had in the applications that we were running based on the generated code and the synthesized code. If you remember, there was like in the app on the laptop, there was a button which said emergency stop. So actually, like we have, it looks like we have two different implementations of the emergency stop. One based on hardware, right? This cable poking out here, and the other one based on software, the signal that is sent from the laptop. So how do we do this? Do we just say if we have Wi-Fi, then the emergency off switch is implemented using Wi-Fi? Or do we say, well, we have two options for emergency stop, either the physical one or plus the Wi-Fi one. We could say maybe we want both to be implemented. Is there anything that would stop us from doing that? Or would this be another nice product that we could sell? Where we basically allow the emergency off switch to be controlled by the laptop, and in addition to have the variant which is on the robot. Maybe it makes sense. I mean, if it was a larger robot and it's driving around in some populated area, maybe you would want the button to be on the robot itself, like we had here. But in addition, if it's remote controlled, you still don't want to give up this emergency stop feature, right? So how do we model that? That we actually have two different implementations of the emergency switch, and we would allow both of them to be used, right? You could use them together. So how would we express this in our feature model? Yeah? Mm-hmm. And where do we put this or? Yeah, I think that's the most readable. So we put an or here. Do you see it? Yeah. And then we have the emergency, hardware. And we have the emergency software feature, right? We use both in different implementations, and why not combine them? Maybe it helps to make the robot more safe. Did we cover everything? Did we cover all the variants of the existing, like all the features that were independently used in the existing implementations? Should we try to check whether we can derive the existing implementations from this feature model as products? Sorry, yeah.
Requires the ESP32 chip. It was included in the full feature product.
Let me check. So actually, we manage this Wi-Fi manager is an implementation that is. Let's check. I think that is independent of the chip, and I think it's also used in this version. Yeah, so the ESP8266 also uses the Wi-Fi manager. So yeah, there's no issue here. Any other thing? Are there any Crosstree constraints? We didn't really think about that so far, right? Are there any?
When we're writing the code, you mentioned the memory capabilities.
Yeah. No, these are just like, let's say, benefits of the configuration, that there is a lower memory footprint for one version or the other. So this actually depends then on the variation mechanism, because we might be able to implement this feature model with different variation mechanisms, and some variation mechanisms might not have the benefit of lower memory footprint. So for example, if we say we implemented using parameters, so that you tell the chip in the beginning, or you tell the program in the beginning what features it activates or not, then the compiled code would even be probably larger than the maximum of the different variants right now. So if we would use the this variation mechanism of configuration at runtime, then we would not have any benefit in terms of memory consumption. We would even make it worse probably. But that's fine for some systems, because there it maybe doesn't matter. One thing is that, for example, this robot could be implemented using a different chip. We could implement it using an Arduino Nano, for example. The Arduino Nano doesn't have any Wi-Fi capabilities. So, but it can do most of the other stuff. I'm not sure. Should we? Yeah, let's just do that, just to illustrate that. So I'm putting this inside the exclusive OR. Let's put the Arduino Nano here. And then we have some issues, because the Arduino Nano can't handle Wi-Fi. So what we would have to say, how do we say this? Let's just write it as Crosstree constraint, not make it visual, because yeah, I think it gets too complex then. So how would we write this as a Crosstree constraint that we can't have Wi-Fi when we have the Arduino Nano? Yes. So yeah, so the Arduino Nano as a chip would exclude the Wi-Fi. What about Wi-Fi manager? Do we also need to exclude that? Yes, we are excluding the parent feature. So this means there's no way that Wi-Fi manager could ever be included. So we're fine. We don't need to exclude the child features. Now, do we have other Crosstree constraints? If not, then let's go and create some of the, let's see if we can create our products, right? So this feature model, we're hoping that at least it can cover the features of the 1, 2, 3, 4, 5 implementations that we have here, right? If it can't cover those features, then we made a mistake, because then we can't even derive the products that we already have, right? So let's see, can we derive them? So the full one, the full featured, that's the one we always used. So let's call it full. Well, it has bot. The chip is, in this case, ESP32. Then it has, let's check if it has tracing. Whereas the full one, here's the full one. So if it does stuff like this, printing on the serial line, so it has the tracing feature, maybe to different extents, not 100% sure. So it has tracing. Then, actually, it had the emergency switch, but it didn't have the hardware switch, because that's a new edition that was only for this one implementation, the one that was purely hardware based with no, purely without Wi-Fi. So we have emergency switch, but only the emergency software. Oh, switch and software have the same. I use the same abbreviation here, which doesn't make sense. So let's just call it emergency. Emergency, then software, and then hardware, because the features should have different names. So then we had the Wi-Fi and the Wi-Fi manager. So we had, basically all of the features except for the emergency hardware button and the two chips that we didn't use, because we only used the ESP32 here. So then this ESP32, this was basically I created it based on the ESP8266, because I thought that it would solve the performance issues, which it didn't. But the only difference was basically that I replaced the chips, and the rest of the functionality I kept the same. So yeah, very similar configuration. Then let's look at maybe the one that I demoed as the first one, that basically took the ultrasonic sound measures and just was driving. Didn't have any fancy, didn't have tracing. Let's check. These are all the full ones, the drive one. We're setting up the serial port. It had tracing. Okay. I'm sure I created a variant without tracing for performance issues, but never mind. So let's express that one. So how do we, this is the, what was it called? Drive. I think it was just called drive. So the drive variant, the drive product has bot. The chip here was the ESP32. Then we found out that it had tracing, didn't have any emergency switch, didn't have any Wi-Fi. Okay, so that's that variant. What other variants did we have? We had the one with the emergency off that basically was the same thing, and we just added an emergency and we implemented it with hardware, right? Right there. Which one are we missing? Basically the one without the Wi-Fi manager, right? So we have this full version, and there we had a version called, basically we had a version where this one was removed in, I think the one was called lean. Okay, so we are able to show the different products from this product line. Now, let's actually,
Do you want to include the emergency hardware as well?
No, these are the existing implementations. So the existing implementation of the full-featured one didn't include the emergency hardware because this was something that that was only possible later. So basically, it was a translation of the version for the ESP8266, which actually the emergency stop hardware is based on capacitive touch pins, which were only introduced in the ESP32. They didn't exist in the ESP8266. Which means we have another Crosstree constraint because the hardware is different. So actually, if we want to use that implementation of an emergency hardware switch, then we need these capacitive pins, which neither the ESP8266 nor the Arduino Nano have. You can, of course, implement other types of buttons, but actually this one that is used in the implementation of the robot that we just saw, this is only possible in the ESP32. Yeah, the touch function. So how do we express that? So the emergency hardware, EMG hardware requires ESP32. And then it automatically is excluded from the Arduino Nano because this is with an XOR with the ESP32. Okay. Are we done with the feature model? To the best of our knowledge, yeah. So now we have the feature model. We extracted the features into a feature model. We listed the existing products, and do we have additional ones? I mean, we can probably easily identify additional ones. Are there additional products that we might be able to configure that we didn't have before? And you already asked the question about what about the emergency hardware? Should it be in the full featured? It was not, but we can create, of course, a version that simply has the emergency stop hardware added because it's just in an OR relation, and it only works for this one, which has the ESP32. It doesn't work for this one because that we couldn't edit there. Okay, so we have an additional one. Now let's move on. Now, how do we actually implement this in our in our code, where we would then be able to extract all the different products from a common code base. So we're going to use the define keywords and the ifdef keywords for macros in Arduino. This Arduino language is based on C, so it uses very, very similar keywords. So we use this ifdef from C. It's supported in Arduino. And here we might want to restrict ourselves to the most interesting features. So stuff like features bot, we probably don't need to to introduce as a define, and stuff like chip, maybe also not, but the variants of the chip, we would want to introduce those, right? So let's maybe start with something very simple. So if we wanted a minimal variant, what would be a minimal variant implementing the robot? Maybe one that we don't have so far. So basically, leave out everything that is optional. Which part is not optional? Yeah? The chip part, yeah. So basically, bot chip ESP32. That would be the most basic variant, right? So let's now start with one of the code. So let's take the let's maybe start the emergent, take the emergency one and rename it to, let's call it all. It's going to get messy because now we actually need to do some reverse engineering of this code and try to create a software product line from that. Okay, so this is the one that just has the motors, distance. There is some code here that relates to features, right? We have this serial print line here. Which feature does the printing on the serial port relate to? The tracing feature, yes. So let's define the features. So this one has the tracing feature, and here this touch thing, that's the emergency off feature, right? So let's just create the normal feature definitions of the ones present here. We have the emergency hardware. Now, which part in the code do we need because we have the tracing feature? So for example, the initialization of the serial port. If we wouldn't have the tracing feature, we wouldn't have that, right? So what we can do is we can say if tracing is defined, then we have this tracing feature. Oh, sorry. And then we need to end it at some point with an end if. So basically, it's maybe a bit limited, but basically this line here, we only need it for the tracing feature. Are there other lines that we need for the tracing feature? Well, basically, whenever we print something here on the serial port, right? So this one, we're printing something again. Oh. What keyboard layout? Why do I have UK keyboard layout now? So another if def for the tracing. Another if def here for the distance stuff. Now then we need all the end ifs. Was that it? There's no more serial print here. So now let's close all the end if stuff. So now we have kind of isolated the code that belongs only to the tracing feature, right? And only if tracing is defined, then we actually do have the tracing. Now let's do the same thing for the emergency hardware switch. So we can now, again, identify the code that is used for the emergency hardware thing. So there's something here, the touch read, that is only needed for the emergency hardware thing. So we say if emergency hardware, then of course we need to make sure that we close the endif. Anything else? We have, well, this part here of the if, right? The else and, no, sorry, that's the wrong one. This one actually. This one, right? The stopping. This belongs to this if, and that's actually related to the emergency hardware stop. So now we're going to do something which is making the code much less readable, because we are just cutting portions of the code wherever we like, we even breaking this if statement here. So we say this if statement is included if we have the emergency hardware. And then here we're cutting this out also. Okay. Let's check that it still compiles. That we didn't break anything, but I mean all the if-defs they basically were there. So let's have it compile. Almost. Great. Still compiles. That's a good thing, right? Now let's try. So now we already implemented some of the features. We implemented the tracing feature and the emergency stop hardware. Now let's see if we can actually have the most basic version where those two features are not enabled. So now to basically disable these features, we can simply, actually not sure that this works. Let's try. Yeah, we can simply comment them out. And then just to make sure that this actually not only compiles, but also works as intended, we will try to upload it to the robot. We already see some benefits. Instead of 18% of the program memory, this only takes 16%. So yeah, there's some indication that we have a more simple variant compiled right now. Doesn't twist like that. Okay. Okay, emergency off feature doesn't work. Well, sorry? Let's see. We wanted to turn the tracing off, right? Anyways, for the tracing to work, we need the USB cable connected. So let's do that. And then let's check whether we're getting anything on the serial port. Which one was it? This was our variant here. So let's open the serial monitor. And yeah, it looks like it's still running, but there's no tracing. So we turned it off. Very good. Now, I can actually leave it connected. So now it gets slightly more complex because the next step we would want to do is add additional features. Oh no, now I need the camera again. So what would be a good feature to add next? The Wi-Fi? Yes. So for that, how do we add the Wi-Fi feature? So this is our variant where we want to, so this was the mini variant where it now really takes very little amount of memory, both the program storage and the dynamic memory. So that's very good because we just disabled the features. Now, how would we add the Wi-Fi? So basically we have to take, this one is on the left, we have the version with the lean version without the Wi-Fi manager, right? So there's some stuff that is new here. So what we would do is we would have another ifdef. Let me just copy this ifdef block. Now this ifdef is Wi-Fi. And then if we want Wi-Fi, we include those two libraries. But there's a lot more code that is required for the Wi-Fi. So for example, here this HTTP client, right? That's something. So now we're basically going over the code and collecting the stuff that we require for the Wi-Fi functionality. This is very, maybe error prone. So let's say I forget to copy these two lines. Then let's see where this gets us. So here we create the portal. This stuff is new. We need it here. And the end if. So let's say I would have forgotten to put these two lines. So let me just check right now if it still compiles. I mean, we're not done yet. I just wanted to demonstrate one of the possible pitfalls here. So this one, we didn't even, so it still compiles, but we didn't turn on the feature Wi-Fi, right? So let's turn on the feature Wi-Fi. Where do we have the features? Here. Let's enable the Wi-Fi and then see what happens. So it was previously compiling, and now hopefully it compiles again, but based on the background implementation, there's no guarantee that now it still compiles. So it could be that some combinations of features actually make it impossible to compile. I think we don't have this kind of interaction yet, but let's see what happens. Okay, well, we jumped from, what was it, 16% to 48 because we have all this Wi-Fi stuff inside. Now, let's say I don't know, make a typo or something like that in one of the blocks only. It's much faster now because it's no longer compiling. And the reason is here that it tries to wait, it's not that line. should be this line here. Why does it say? So it's not even able to show us the right line that fails. So it says here, I know it says Wi-Fi has not been declared in the scope. Is that correct? This HTTP thing is the one that shouldn't exist, right? Yeah, so basically because of a typo here, I was expecting, and somehow it also somewhat happened. I don't know why it also complains about the Wi-Fi, but here it complained about the HTTP because that hasn't been defined because now it was not included. So now because of this mistake here, but now let's see what happens if we actually never tried to use the Wi-Fi at all. So we still have this bug here that this part doesn't exist when somebody wants the Wi-Fi, but currently we didn't want the Wi-Fi, so everything compiles because we didn't try to include the Wi-Fi. So the problem with this is that it's really, really difficult to analyze the configuration mechanisms with these if-defs, because the compiler will not check all the variants. The compiler will check the currently defined variant. So that's one of the quite big challenges here. Now it gets a bit more messy because we actually see that there is additional stuff going on. There is here the tracing. So the Wi-Fi one doesn't only contribute implementation to the Wi-Fi implementation, it also has contributions to the tracing implementation, but that's fine. But now we actually have to copy the tracing stuff as well, right? So let's go back to this loop. I don't know, maybe here. This stuff is tracing. And then we have this stuff, which is clearly Wi-Fi related. Do I copy everything? Let's just copy everything to make it easy. So now if def Wi-Fi, and if, then we have this nice loop here. Okay, so is this fine? So what happens if we select the original configuration of emergency stop and tracing and not Wi-Fi? Should we try it? So let's have emergency stop and tracing, not Wi-Fi, because we're now basically expecting this similar behavior to what we had in the beginning, right? So let's try to upload this. Should go fast again. And we need to turn it on. So compilation goes reasonably fast. Now it's trying to connect. Okay. And uploading, and then we open the serial monitor. Let's see if the distance sensor still works. But now it's telling us something about HTTP stuff. It wants to do an HTTP request. But that was actually just related to the Wi-Fi. So here, the issue is that this doesn't exclusively belong to tracing. This one actually belongs to the feature tracing, but only if the feature Wi-Fi exists, right? So this trace message here that it's trying to establish an HTTP connection, this is from the Wi-Fi related code. So what we would now need to do is we would need to make sure that the code that belongs to different combinations of features also only appears in that combinations. So here we might want to, or maybe the outer one. So if there's Wi-Fi and if we're asked to have the tracing feature, then we're actually printing that tracing message. So this like dependency between features, this also needs to be reflected in the implementation, which makes it a bit tricky, right? Now, the problem with this is that the creation of these ifdef based code to extract it from existing versions is actually quite difficult and error prone for various reasons. Now, is there maybe a way to do this automatically? Because we have the implementations, right? Now we're just copy and pasting stuff. Is there a way to automate this? It's not so easy because we have these relations between features, right? We could, of course, say this whole file on the left here, this is only relevant if we have a specific feature combination, right? So we could say ifdef Wi-Fi, ifdef tracing, ifdef ESP32, ifdef Wi-Fi manager, then copy that code, end if. But the problem with that is then we would not be able to configure the features independently. Here, what we want to do is we want to turn stuff independently on and off. So if we would just copy the whole implementation and say this is only active when this one particular combination of features is active, then we're not really having a software product line. Then we have a bunch of variants in one file, but that's not what we want. We want to be able to independently turn features on and off, and that's why we need to be aware of the dependencies between features also in the code that we are creating with the ifdefs. Okay. So we haven't completed this, but I think it's fine. We saw the main challenges of this, but still it's the most common way that it's done in industry. So here we're having this kind of reverse engineering challenge. If you start from scratch, maybe it's a bit easier because you can organize the code maybe a bit nicer based on the features, but if you have already the products of the product line and you want to start creating a software product line from it with this variation mechanism, then it's not that easy, and there's some challenge in creating the code. But then once we would have it, we could easily maintain and extend it to new features, and we can easily generate new variants out of it. Are there any questions? Any questions in general about software product lines? Okay, then I think we can complete this part and maybe already start motivating the next section. We still have, I think, 20 minutes to give an overview of what will happen next. By the way, also all these implementations, if you want to, if you want to complete this software product line or inspect the versions, they're all on GitHub. It's a public repository where also the code of this execution of the code generation is. So here we had these spectra specifications, and we also have somewhere in the code folder these state machines, the ample state machines. So yeah, if you want, you can you should be able to run all of these. For the ample, you need to install a plugin, but I think it's somewhere in the somewhere in the README that you need to install the ample plugin. So if you want to play with this, then it's all publicly available.